Okay, for today, this is called factored form and zero product property. So that is where you have something like this. There are two things that are multiplied together and equaling 0. If that's the case, do you get one of them has to be 0? There's no way to multiply two things and get 0 unless one of the two things is 0. So then you just set A equals 0 or B equals 0. One of those two things, right? So our problems typically would look like this. X plus 6 equals 0 or x minus 5 equals 0 because the total is 0. So then you could say x plus 6 equals 0 or x minus 5 equals 0. That's called the zero product property. You've been doing this for a long time. It's on top 20, so you should be pretty fresh with this. So let's look at ones that sometimes kids wonder, is this factored? Like, look at that. Is that factored? There's no parentheses, but it's still a multiply, so that's factored, yes. So that is one of those kind of questions. Can you make a 15 into a 0? No, it doesn't make any sense. Can you make an x into 0? Yes. So what's the only way this would work? Not if 15 was 0, but if x was equal to 0. All right. How about on this one? Well, either 2x minus 1 has to equal 0, or 3x minus 4 has to equal 0. One of those two things has to be true. And then you can solve them down. Again, I hope this is firmly in your wheelhouse. Set up little equations, solve them. This is no big deal. Okay, so let's talk about what those are, though. In the big picture, those, I know they're answers, but what are they? If you were to look at a picture of this, it would have been a parabola. Would it have been right side up or upside down? Well, there's no negative anywhere, so this would have been a U-shaped parabola that touched at 1/2 and 4/3. I get to make up where 1/2 and 4/3 are. I'll say that's 1/2. I'll say that's where 4/3 is. And that's the two spots it hit. It's a parabola that touches at 1/2 and 4/3. Those are the roots, the zeros, the x-intercepts, the solutions. Okay. Why doesn't this work? Why can't you do this one? Doesn't equal 0. Could you multiply it all the way out and then subtract 5 so it equals 0 and then refactor it? Yes, you could. That would be a ton of work, but you could do it. You couldn't do it the way it is, though. Can't have a 5 there. You could multiply this all out, then subtract 5. It would work. It'd be really long. All right, how about this one? Will this work? No, because two things are equaling 0, but they have this little plus 5, and that means it's just like having a negative 5 over there. That can't work. It has to be equal to 0, and it has to just be two things multiplied. So that one will not work either. All right, on to this. The x-intercepts are the zeros, the solutions, the roots. If you've got factored form like this, then you know the two x-intercepts. We just talked about that 2 seconds ago. All right, next slide. How can I find the vertex and the axis of symmetry from factored form? So let's say I had factored form. Then, how do I find the vertex? Who's got a good short-term memory and remembers the little formula for the vertex? Negative b over 2a. Excellent. But there's a better way. Why? Well, this way is awesome if you have general form, because then you'll have a, b, and c. Can you just look at this and know what a, b, and c are? No. So that's kind of not a great time to use negative b over 2a. So there must be another way. Do you get that this little blue line, the thing that runs right down the middle, that is in between this and this? It's exactly between 3 and negative 5. So when I ask you math-wise, what is exactly between 3 and negative 5? I'm actually asking you for the average of them. It's a lot easier if there weren't one positive and one negative. If I said, what's exactly between 4 and 6, you would say 5. And that is the average of 4 and 6 also. If you've ever thought about it, that's what average means, is the number that's exactly between the two things. A lot of times when you average, you have like 3 things or 5 things or 7 things. And then it means kind of the number that best fits in the middle of them. But when you only have 2 numbers, it's super simple. If I have 5 and I have 6, what's the average of 5 and 6? 5.5. It's exactly between them. So when you want the thing that's exactly between them, you really want the average. So if I have these 2 numbers, 3 and negative 5, what's exactly between them? The average. How do I average them? You add them together and divide by 2. What is 3 and negative 5 when you add them together?
2.
If I add them together, I get negative 2. And then I divide by 2, and I get negative 1. So negative 1 is the average of the 3 and the negative 5. All right. Imagine for a second you have a parabola, and it looks like this. And this is 6, and this is 8. What's the dotted line that runs right down the middle? X equals 7. And that's the axis of symmetry. See how easy it is to find the axis of symmetry? You don't have to multiply it all the way out. This would have been x minus 6 and x minus 8. You wouldn't have to multiply this all the way out. Find a, b, and c. Then do b squared minus, no, what is it again? Negative b over 2a. You don't have to do all of that. You can just find the number that runs right down the middle of them. All right, but how do you finish it and get the vertex? This is the axis of symmetry. How do you get the vertex? Then you take this 7 here, and I know the vertex is 7 comma something, and I stick the 7 in to the equation. Watch, if I put in a 7 and a 7, I get 7 minus 6 is 1, and I get 7 minus 8 is negative 1. What is 1 times negative 1? Negative 1. That's 7, negative 1. So that last part, it really isn't that hard. You take the x number you found, and you stick it in the equation over here. All right, let's try one more like that. What are the roots? Negative 5 and positive 4. Negative 5 and positive 4. And now I'm asking what's exactly between the two of them, because that's what that dotted line down the middle is called, the axis of symmetry. Well, to do that, I average them. So I add them together. What do I get when I add negative 5 and 4 together? Negative 1. But then I divide by 2. And what's that? Negative 1/2. So the lines that runs right down the middle of these two would be x equals negative 1/2. Then what do? You put that back in here. That makes 4.5. That makes negative 4.5. So it's going to be 4.5 times negative 4.5. Gives you your y. The vertex would be negative 1/2, comma, whatever, 4.5, which is like 9 over 2, times negative 9 over 2. That's going to be negative 81/4. You probably wouldn't have one that bad on the test, but you never know. It's not that hard. You just had to take 4.5 times negative 4.5. All right, I'm going to give you one more. It's going to work out nicer. Y equals x minus 6, x plus 4. Would you please find the axis of symmetry, hint, the axis of symmetry, and the vertex? Pause for a second while you try that. All right, let's see how you did. I hope you thought 6 and negative 4 are the two important numbers. And what's exactly between them? You could draw it. Here's 6, here's negative 4. If you did, you'd know that the dotted line would run kind of to the right side of the origin. You could just add them together and you get 2. But then you divide by 2 and you get 1. What's that? Axis of symmetry. Good. So if the axis of symmetry is at 1, then that spot right there, the vertex, would be 1 comma. What do you do with the 1? Plug it into the x. So 1's here, 1's here. I get -5, I get +5. You're going to notice that that happens a lot, where you get the exact opposites. 5 times -5. All right. So in this case, 1 comma what? -25. That's the vertex. Raise your hand if you had 1 comma -25. Okay, awesome. Now write the equation in vertex form. You have the vertex. The same equation we had can be written now in vertex form. Remember how to do that? X minus 1, don't say +1 by accident, squared, and then -25. Raise your hand if you had that one right. Okay, awesome. That's vertex form. That's factored form. What's the only form we don't have? General. I'm not going to make you do it, but generally you just what? Multiply it out. It's already factored. Multiply the factored form out would be the easiest way. Okay, let's go on to the next page. If they wanted general form, we just talked about that, generally you would just what? Multiply that out. So we're not going to do that. How about axis of symmetry? It's the axis of symmetry. It's x equals something. Do you want to multiply it all the way out and then do -b over 2a? I'd rather not. How about instead we do that deal where it's between -5 and +1. What's exactly between -5 and +1? -2. How'd we get that? We added these together and divided by 2. Okay, so x equals -2. Is that the vertex? No, that's part of the vertex. How do we get the last part of the vertex, Gracie?
We get the last part of the vertex by putting, sorry.
It's all right, you're doing good.
We put it in, we put the x into the x, in factored form.
There you go. And now the -2 goes in there. And I got -2 plus 5, and I got -2 minus 1, and that's going to make a 3 and a -3. Told you it often happens. 3 and -3. All right, so that makes -9, and then I times it by -2. -9 times -2. How many got +18 before I did? Awesome. Okay. There's not much more that we have to learn here. There is a little bit more. Do you get a lot of people graph this one and they go, okay, it goes through -4, It goes through +2, and they graph it like this, and then I mark it wrong. Why?
It's reflected.
Because it has a negative in the front, so it's upside down. All right, now that I've got that, what is the actual question? What's the vertex? We've done this enough times. You'd find the line that goes right down the middle, and that would be the x equals. That'll be too easy. Let's go on. On this one, the only thing that's different about this one is there is no equation. I want to do this in 2 halves of the room. The room that's got the half of the room that's by the door here, rows 1, 2, and 3, I want you to use the points 1 and -3, because that's what those are, in case you're having trouble figuring out where the axis is. Those are the points 1 and -3. I want you to write the equation with that. And this side of the room, rows 4, 5, and 6, you guys use this vertex right here, which is at -1, -4. You guys write it in vertex form. Because you could do it either way. Rows 1, 2, and 3, you're doing the factored form. Rows 4, 5, and 6, you guys are doing vertex form. If I had to pick between those two, I think I'd rather write it in factored form. Here's what you guys in factored form should have wrote. x plus 3, x minus 1. Raise your hand if you guys had that one, right? Okay, good, down on this side of the room. But I'd rather have it in vertex form, because vertex form, when you have that, is really handy because you can find the vertex really easily, and that's a really powerful point. So I'm going to say x plus 1 squared minus 4. Did you guys on the right side of the room over here, did you guys have that right? Okay, good. Okay. Is either one of these better than the other? Well, it depends on what you want. If you want the vertex, that's better. If you want the factors, that's better. I shouldn't say factors. The roots, the zeros, the x-intercepts. How about which is easier to multiply out and get general form with? Probably take factored form. I'd rather multiply this out than multiply that out. Personally, I'd rather have the factored form for multiplying it out to general. All right, but there's advantages and disadvantages to both, and that's something that we can ask you, is what are the advantages of each form? All right, on to this one. What form is this in? Vertex or factored? It's clearly not general. What is it? That's vertex. So we know the vertex like right away. All right, so that's the question. How could we write the equation in factored form? Ew. You could, well, you guys tell me. What would you do? If you had to get this into factored form, what would you do? Raise your hand. Somebody tell me what you'd do. If this is the test question, what would you do?
Find the vertex.
Okay, we'd find the vertex, and that's at 3 comma negative 4. I might even draw my little parabola in. That's a really rough parabola, but that's kind of it. And then what? Find the axis of symmetry. Okay, then I could find the axis of symmetry. It runs right down there, and that's pretty easy. That's x equals 3. If I wanted factored form, what are the most important things then? If I want factored form, if I want this to look like this, then what do I really want to know? The roots, also known as the x-intercepts. Can you tell from looking at this? I mean, my graph is pretty bad. I kind of on purpose did a really bad graph so that we couldn't just go, oh, there they are.
You could use the axis of symmetry.
Okay. You could use the axis of symmetry. How are you going to use that? What you should do? All right. I'm going to keep it simple for you. If I had to do this problem, I would multiply this thing all the way out, and then it'd be in general form. And one of the things that's good about general form is then you can just factor it. Do you get what I'm saying? Getting it from the picture is actually kind of a pain. I could go to I was kind of disappointed nobody said my XY chart. I could do that, stick in points until I finally found the ones that hit the x-axis. You know what I mean? That could work. But I think the best way, everybody just multiply this out, get general form, and then it'll factor. Go ahead, give that a try. Please don't say that's x squared plus 9, because it's not. I got x squared minus 6x plus 5. Did anybody already get that? Sweet, beat me. Then it can factor, and you'll have factored form. X and x, how do you make a 5? It's got to be a 1 and a 5, doesn't it? And then, is it just 2 pluses or 2 minuses? How did I know it wasn't 1 minus and 1 plus? Because that's a positive 5. You have to multiply these two numbers together. If they're both negative or they're both positive, you could get it to be positive 5. It has to be 2 negatives. There we go. We got it in factored form. Is there other ways we could have done it? Yes, but I think this is the easiest way. How do you get general form? Generally, you just multiply it out. Once it's in general form, then it can be factored. All right, moving on. Take a look at this one. What is the y-intercept? Ooh, finish this sentence. The y-intercept is where? X equals 0. So I just put a 0 in, and that's it. Don't have to do something really complicated here. All right, on to the next one. On this one, the x-intercepts, because they gave me the picture, it's so obvious. They're 1 and 3. Can I just write 1, 3? Remember, that's called a bald answer, so we're not going to accept that. So what is it? X equals 1 and x equals 3. What if you wanted to write it as a point? Well, they're x-intercepts, so y is 0. So 1, 0, and 3, 0. Those two ways are okay. The equation in factored form. Everybody write this equation. Hopefully this will be like, oh, that's easy. Equation in factored form. All right, x minus 1, x minus 3. I just got it wrong. So easy to not catch this. Who's caught one little thing that I didn't catch? Ooh, you're having a good day today. There has to be a negative in front. Did you guys even notice it was an upside down parabola? So easy to forget that. There has to be a negative in front here. Why? Because it's an upside down parabola. All right. Equation in general form, then generally you just multiply it out. Let's multiply this one out. We've skipped a lot of those because I say it's easy, but let's make sure it actually is easy for you. Multiply that puppy out. Don't forget the negative in front. I'll pause for a second while you give that a try. All right, so this one you'd have x squared minus 4x plus 4 without that negative in front. So the negative is still there, but I can't just slap it on the first number. I think you know that. So now I'm going to put that negative with everything, and I'll have negative x squared plus 4x minus 4. Oh, I got something wrong there. Sorry. 3 times 1 is not 4. Oopie. Backing up. 3 times 1 is not 4. Keep saying that to yourself, Mr. Server. 3 times 1 is 3. Okay, then the negative goes in front, and then I have negative x squared plus 4x minus 3. There we go. And you know what? Honestly, when you said that, I was just going and looking at the y-intercept up here, and I was like, wait a minute, the y-intercept is negative 3, but I have a negative 4 there. What's going on? And I was catching myself at that moment. All right. Yay. That's called general form. Do you think it could be factored? Of course it could. It's right there. It's where it came from in the first place. But pro tip, you ever want to factor something that has a negative in front? Factor the negative out. Then it'll factor a lot easier. I'm going to show you that again on a new one so that everybody tries it. Ready? Y equals negative x squared minus 6x minus 5. If you try to factor that, you're going to have all kinds of problems unless you factor out the negative first. Try that. X plus 5, x plus 1 with a negative in front. Looks like it's an upside down parabola. It goes through negative 5 and negative 1. Kind of like that. Okay, I feel like you got everything that you need to be able to handle this. So you have a Schoology quiz, and now you have enough time to probably finish it in class. So work on it. If you get stuck, bring it up to me. Usually the questions are like, how do I put this into Schoology? Don't forget that you need the little squareds are like this. If you want to put in x squared, it's like x to the second. And never put in spaces on Schoology. And if you're not sure whether to type in y equals or not, look really close. Usually you don't have to type in y equals to make it an equation, because usually there's already like an f of x in front of the blank. So you usually don't type in y equals at the beginning of your equations. Okay, that's all I have for you for the video for today.